You know, there is a feeling you have right now. You can feel it in the seat of your pants as you sit in your chair. You can feel it in your feet if you're standing up. It's a heaviness, a weight, a persistent, relentless pull that never stops, not even for a second. We call it gravity. And we are told from the time we are little children in school that this is a force. We are told that the earth is like a giant magnet and it is pulling you down toward the center. We are told that the moon orbits the earth because there is an invisible rope of force swinging it around. It's a beautiful story. It's simple. It makes sense. It allows us to build bridges and fly airplanes and land men on the moon. Isaac Newton gave us the mathematics for it 300 years ago, and it works. If you want to calculate how long it takes for an apple to hit the ground, Newton is your man. But I have to tell you something that might disturb you a little bit, something that might make you look at the floor differently. It is all wrong. Gravity is not a force. The earth is not pulling you down. You are not heavy because of a tug of war between you and the planet. In fact, if we look at the universe the way it really is, the way Albert Einstein showed us, there is no such thing as a gravitational force at all. What you are feeling right now, that pressure on your chair, isn't the earth pulling you down. It is the earth pushing you up. You are trying to follow the natural path of the universe, a path that is curved and beautiful, and the ground is getting in your way. The ground is interrupting your fall. You are essentially in a car that is constantly accelerating upward, and you are feeling the seat press into your back. Now, I know what you're thinking. You're thinking, Richard, that sounds crazy. I can see things fall. If I drop my keys, they go down. They accelerate. How can you say there is no force? Well, to understand this, we have to go back. We have to look at the problem that Isaac Newton left us. Newton was a genius, maybe the smartest man who ever lived. He realized that the same thing that makes the apple fall is the same thing that keeps the moon in the sky. That was a huge leap. He wrote down an equation, force equals mass times gravity. It was perfect, but Newton had a secret. He knew his theory had a hole in it, a big gaping hole. He knew how gravity worked mathematically, but he didn't know what it was. Here's the problem. Look at the sun. It is 93 million miles away. It is holding the earth in orbit. But how does the earth know the sun is there? There is no rope. There is no chain. There is just empty space. How does the information, I am here, come orbit me, get from the sun to the earth? Newton assumed it happened instantly. He thought if the sun disappeared right now, the earth would instantly fly off into space. But that doesn't make sense. Nothing is instant. Even light takes 8 minutes to get here. If the sun vanished, we would still see it for 8 minutes. We would still feel its heat for 8 minutes. So why would we feel its gravity instantly? Nature doesn't allow spooky action at a distance. You can't touch something without reaching out. You can't push a car without touching the bumper. So how can the sun push the earth across 93 million miles of nothing? This bothered physicists for 200 years. They tried to invent invisible fluids, ethers, things to fill the space, but nothing worked. Then came Einstein, and Einstein had what he called the happiest thought of his life. It wasn't a complex equation, it was a simple picture in his head. He imagined a man falling off a roof. Now, I hope the man is okay. Let's imagine he falls into a safety net. But while he is falling, Einstein realized something profound. While the man is falling, he does not feel his own weight. Think about it. If you are in an elevator and the cable snaps, don't worry, the emergency brakes will work. For a moment, you float. If you drop your keys, they float right next to you. You don't feel heavy, you feel weightless. Now, astronauts in the space station, they are floating. Why? Is it because there is no gravity up there? No, that's a common misconception. There is plenty of gravity up there. The earth is still pulling on them almost as hard as it pulls on you. They are floating because they are falling. They are falling around the earth. And when you fall, gravity disappears. Einstein looked at this and said, wait a minute. If you can make gravity disappear just by falling, maybe it's not a real force. Compare it to electricity. If you are in an electric field, you feel a push. You can't make it disappear just by moving. It's always there. But gravity, you can cancel it out completely just by letting go. This led Einstein to a new idea, the equivalence principle. He said, imagine you are in a rocket ship in deep space, far away from any stars or planets. Everything is floating. There is no up or down. Now turn on the engines. The rocket accelerates upward. What happens? The floor comes up and hits your feet. You feel pressed into the floor. If you drop a ball, the floor rushes up to meet it, so it looks like the ball is falling. Einstein said, there is absolutely no experiment you can do inside that rocket to tell the difference between accelerating in deep space and sitting still on Earth. They are the same thing. And if they are the same thing, then maybe what we feel on Earth isn't a magical force pulling us down. Maybe, just maybe, we are accelerating. But how can we be accelerating? We aren't going anywhere. The room isn't moving. If the Earth is pushing us up, it would have to be expanding like a balloon, getting bigger and bigger every second to keep pushing us. And obviously the Earth isn't blowing up. So how can you accelerate without changing your speed? How can you move without going anywhere? This is where the geometry comes in. This is where the genius lies. Einstein realized that we have been looking at the stage wrong. We think space is a flat, rigid box that things move around in. We think time is a steady clock ticking on the wall. But nature says no. Nature says space and time are flexible. They are a fabric. And this fabric can curve. Imagine a trampoline. You put a heavy bowling ball in the middle. It sinks down. It creates a curve, a valley. Now take a marble and roll it across the trampoline. Does it go in a straight line? No. It curves. It circles the bowling ball. Now look at the marble. Is there a rope pulling it to the bowling ball? No. Is there a magnet? No. The marble thinks it is going straight. It is just following the curve of the fabric. Mass tells space how to curve. Space tells matter how to move. This is the secret. Gravity isn't a force reaching out and grabbing you. Gravity is the shape of the universe itself. The sun is heavy, so it bends the space around it. The Earth is trying to move in a straight line, but the space it is traveling through is curved, so it ends up going in a circle. It falls around the sun forever. But wait, we have to be careful with the trampoline analogy. It's not perfect. It's 2D, and we live in 3D. And more importantly, the trampoline only works because gravity pulls the bowling ball down. We can't use gravity to explain gravity. That's cheating. So we have to look deeper. We have to look at the curvature of time. This is the part that really bends your brain. Gravity doesn't just bend space, it bends time. The closer you are to a heavy object, the slower time flows. This isn't science fiction. We have measured this. If you put a super precise atomic clock on the floor and another one on the table, the one on the floor ticks slower by a tiny, tiny fraction of a billionth of a second. But it is real. Your feet are actually slightly younger than your head. The core of the Earth is more than 2 years younger than the surface because of this time dilation. So how does this create gravity? Everything in the universe is always moving. Even if you are sitting still in your chair, you are moving through time. You are traveling toward tomorrow at a steady speed. But because time flows slower near the ground, the lower part of you is moving through time slower than the upper part of you. Imagine driving a tank or a bulldozer with 2 tracks. If the left track moves slower than the right track, what happens? The tank turns. It turns toward the slow side. That is exactly what is happening to you right now. You are hurtling through time, but your feet are dragging slightly compared to your head. This difference in the flow of time causes your path through the universe to curve. It curves toward the slow time. It curves toward the Earth. You are trying to move in a straight line through space-time, but the mass of the Earth has warped the time stream, bending your path downward. So, naturally, you want to fall. Falling is just your body trying to follow the curve of time. Falling is the natural state. Falling is like floating. But then, wham, the floor gets in the way. The floor is a solid object. It has electromagnetic forces holding its atoms together. It refuses to let you follow your natural curved path. It intercepts you. It pushes you. So the weight you feel, that isn't gravity pulling you. That is the electromagnetic force of the chair pushing you away from your natural path. Gravity is the curvature. The force is the ground hitting you. This changes everything. It means that when you drop a ball, the ball isn't really accelerating. The ball is just doing what nature wants it to do, floating along the curve. It is us, the people standing on the ground, who are accelerating. We are rushing up to meet the ball. Think about how beautiful that is. The natural state of the universe is free fall. The natural state is surrender to the geometry. Everything else, standing, sitting, building, is a struggle against the curvature. Now you might ask, okay, Richard, this is a nice philosophical idea, but is it real, or is it just a fancy way of doing the math? It is very real. And we know it's real because Newton's math failed. For centuries, astronomers looked at the planet Mercury. It's the closest planet to the sun, and it was misbehaving. Its orbit wasn't quite right. It was shifting, precessing, in a way that Newton's laws couldn't explain. It was a tiny error, but in science, a tiny error screams that something is wrong. Astronomers thought there must be a hidden planet pulling on it. They looked for years. They never found it. Then Einstein used his new idea. He calculated the orbit of Mercury not using force, but using the curvature of space and time. He sat at his desk, working through the complex geometry. And when he got the final number, it matched the orbit of Mercury exactly. He said he had heart palpitations. He knew he had found the truth. But the real test came later. If gravity is just curved space, then it shouldn't just affect heavy things like planets. It should affect light, too. Light has no mass. Newton would say gravity shouldn't touch it. But Einstein said, if space is bent, then light has to follow the bend. Light travels in a straight line, but if the ruler itself is curved, the light will curve. He predicted that if you looked at stars behind the sun during a solar eclipse, their position would be shifted. The sun's gravity would act like a lens, bending the starlight. In 1919, astronomers went to Africa and Brazil during a total eclipse. They took photos of the stars. And when they measured the dots on the photographic plates, they found exactly what Einstein predicted. The light had bent. The headlines the next day read, "Lights all askew in the heavens. Newtonian theory overthrown." We had changed our understanding of the universe forever. So why do we still teach Newton in schools? Why do we still talk about the force of gravity? Because for everyday life, Newton is good enough. The curvature of space on Earth is tiny. You don't need Einstein to build a house or catch a baseball. The math of curved space-time is incredibly difficult. 10 equations that have to be solved all at once. Newton's math is easy, so we use the easy tool because it works for us. But just because it works doesn't mean it's the truth, and the truth is so much more elegant. Think about what this means for the structure of the cosmos. It means the universe isn't a static stage where actors move around. The stage itself is an actor. The stage twists and turns and bends. When a star spins, it drags the fabric of space with it like a mixer in a bowl of batter. This is called frame dragging, and we have measured that too. It means that black holes aren't just things pulling really hard. They are places where the curvature becomes infinite, a hole in the fabric, a waterfall of space falling inward faster than light can climb out. It means that ripples can travel through this fabric. If two black holes crash into each other, they send out waves, gravitational waves. We detected these for the first time in 2015. We heard the universe ringing like a bell. That wasn't a force traveling through the void. That was the void itself stretching and squeezing. When you start to see gravity this way, you stop looking at the universe as a collection of isolated objects tugging on each other. You start to see the connections. Every piece of mass, every bit of energy is communicating with the geometry around it. It brings a sense of unity to the physical world. The same geometry that tells a planet how to orbit, tells a beam of light how to bend, and tells time how to flow. So, the next time you drop your keys, don't think of them as being pulled down by a magnet. Think of them as being released. You let them go, and they return to their natural state following the curve of time. They are free. And you You are the one doing the work. You are the one pushing against the universe, accelerating upward, feeling the force of the floor keeping you from following them. Gravity is not a force. It is the shape of reality, and we are just riding the curves. It's a strange thought, I know. It goes against everything your intuition tells you. But remember what we said before. Nature doesn't care about your intuition. Nature works the way it works. And our job is to open our eyes and appreciate the cleverness of it all. The universe is built on geometry. And that geometry is holding you in your chair right now. Isn't that wonderful? Now, if you want to understand how this same geometry allows for things that seem even crazier, like how the universe bends so much that light can get trapped forever, stick around. Because there are parts of this fabric that are so steep you can never climb out. But that is a story for another time. Keep asking questions. Keep looking at the world and wondering why. Because usually the answer is far more beautiful than you expected.